Hi, meet me again in tutorial 2, first derivative. Here are the solution of question from textbook, page 43 and 44. Okay, question number 1A. Differentiate each of the following expressions with respect to x. Okay, so we have to differentiate x plus 4 power of 5. Okay, so to solve this question, actually you can use chain rule. Okay, we have dy dx equals to dy du times du dx. Okay, so let's say we use chain rule. Okay, so let y equals to x plus 4 power of 5 and u equals to x plus 4. Okay, so then y equals to, this one is u. Okay, so u power of 5. Okay, so here we have y in terms of u and u in terms of x. Okay, then we can differentiate. Okay, we differentiate these two things. Okay, u in terms of x, we differentiate, we get du dx equals to 1. Y in terms of u, we have du dy du equals to 5u power of 5 minus 1. So dy du equals to 5u power of 4. Okay, so now by using formula, this formula, okay, this formula. Okay, so dy dx equals to dy du times du dx. Then you substitute. Okay, dy du, this one, 5u power of 4. Du dx, this one, times 1. Okay, but u itself is x plus 4. So then you substitute again. So we get 5 times 1, 5. U is x plus 4 power of 4. Okay, so this is the answer. Question 1b. D dx 2x minus 3 power of 4. Okay, so then let y equals to 2x minus 3 power of 4 and u equals to 2x minus 3. Okay, so then y equals to, okay, 2x minus 3 is u. Okay, so u power of 4. Okay, y in terms of u, you differentiate, we get dy du equals to 4u power of 4 minus 1. So dy du equals to 4u power of 3. Okay, here we have u in terms of x. We differentiate, we get du dx equals to 2. Okay, so we have formula dy dx equals to dy du times du dx. Okay, then you substitute into the formula. Here we get 4u cubed times 2. Okay, so 4 times 2, 8. U is 2x minus 3 cubed. Actually, question number 1 involving composite function because we have here power of 5. Okay, power of 4. Then you can use method 1 by using chain rule. But actually, we have another method. Okay, I'm going to show you easier. Okay, here method 2. Okay, method 2. D dx x plus 4 power of 5. Okay, so you just differentiate as usual. You move in front 5 x plus 4 power of 5 minus 1. Okay, then you differentiate another time the function in the bracket. Okay, differentiate x is 1, differentiate 4 is 0. Okay, finally we get 5x plus 4 power of 4. Okay, Same thing for question 1b. Okay, method 2, differentiate d dx, 2x minus 3 power of 4. Okay, so then you move in front 4, 2x minus 3 power of 4 minus 1. Then you differentiate another time the function in the bracket. 2x minus 3 we get, differentiate we get 2. Okay, so finally 8 times 2x minus 3 power of 3. Okay, same answer. The rest of the question, I'm going to use second method, okay, method 2. Actually, the concept, you must use chain rule, okay. That one is the concept, but actually method 2 is more easier. So, question C, I differentiate 1 over 3, 6 minus 3x power of 6. Okay, here we have 6, 1 over 3. 6 minus 3x power of 6 minus 1. Differentiate another time, we get negative 3. Okay, we simplify. 2 times negative 3 is negative 6. 6 minus 3x power of 5. Question D. Differentiate 4x squared minus 5 power of 7. So this one becomes 7. 4x squared minus 5 power of 7 minus 1. Okay, differentiate. 4x squared is 8x. Okay, so 7 times 8x is 56x. 4x squared minus 5 power of 6. Next, question E. Differentiate 1 over 6x plus 2 power of 8. Okay, here we go. So 8, 1 over 6x plus 2 power of 8 minus 1 times 1 over 6. Okay, so we simplify 4 over 3. 1 over 6x plus 2 power of 7. Still same question F. Differentiate 2 over 3, 5 minus 2x power of 9. Okay, so then we get 9 times 2 over 3, 5 minus 2x power of 9 minus 1. Times, differentiate another time, we get negative 2. Okay, 3 times 3, 3, 2, 6, 6 times negative 2, negative 12. 5 minus 2x power of 8. Then G, differentiate 1 minus x squared cube. Okay. 3, 1 minus x squared power of 3 minus 1. Okay, differentiate. Negative x is negative 1 minus 2x. Okay, we simplify. We get 3, negative 1 minus 2x. 1 minus x squared power of 2. Actually, we can express in simplest form. We factorize negative 1, we get negative 3. 1 plus 2x. 1 minus x squared. The last one for question 1, H. Differentiate 2x cubed minus 4x plus 1 power of negative 10. Okay, so differentiate, we get negative 10, 2x cubed minus 4x plus 1. Negative 10 minus 1, differentiate another time, we get 6x squared minus 4. Okay. So we rearrange negative 10, 6x squared minus 4, 2x cubed minus 4x plus 1 power of negative 11. Okay, this one we can factorize. Common factor is 2. So negative 10, 2, 3x squared minus 2. Okay. 2x cubed minus 4x plus 1 power of negative 11. So I simplify here, I get negative 23x squared minus 2 over power positive, okay, more proper. So 2x cubed minus 4x plus 1 power of 11. Question number 2, differentiate each of the following expression with respect to x. Okay, so let's try question 2a. So d dx 1 over 3x plus 2. Okay, previously we have learned if we have x as a denominator, we cannot differentiate directly. So you have to move up. Okay, so same thing here. So you have to move up 3x plus 2 become power of negative 1. Okay, so then you can differentiate. Okay, so here we have negative 1. 3x plus 2 power of negative 1 minus 1. Okay, times differentiate another time, function in the bracket become 3. Okay, so here we simplify negative 3, 3x plus 2 power of negative 2. Then here we have negative 3, 3x plus 2 power of 2. B, differentiate 1 over 2x minus 7 cube. Okay, move up d dx. 2x minus 7 power of negative 3. Okay, then you differentiate. You get negative 3. 2x minus 7 power of negative 3 minus 1 times 2. Okay, here we get negative 6. 2x minus 7 power of negative 4. Or negative 6 over 2x minus 7 power of 4. d dx 5 over 3 minus 4x power of 5. Okay, move. Become 5 is constant. 3 minus 4x power of negative 5. Okay, so here negative 5. 5. 3 minus 4x power of negative 5 minus 1 times negative 4. Okay, here we have 100. 3 minus 4x power of negative 6 or 100 over 3 minus 4x power of 6. D, differentiate 3 over 4, 5x minus 6 to the power of 8. Okay, so we move up first. Okay, so here we have 3 over 4 is constant. Okay, here 5x minus 6 power of negative 8. Okay, so then we differentiate. Okay, here. Negative 8 times 3 over 4 times 5x minus 6 power of negative 8 minus 1. Okay, times 5. Okay, 2. Negative 6 times 5, negative 30. 5x minus 6 power of negative 9. Or negative 30 over 5x minus 6 power of 9. Then E, the same concept of composite function. Here we go, square root 2x minus 7. Square root actually power of half. Okay, so d dx 2x minus 7 power of half. Okay, so we move 1 over 2. 2x minus 7 power of 1 over 2 minus 1 times 2. Okay, we can simplify. We get 2x minus 7 power of negative 1 over 2. Or 1 over 2x minus 7 power of half. Or becomes square root 2x minus 7. F, differentiate square root 6 minus 3x. Okay, so become 6 minus 3x power of half. Okay, so differentiate No more d dx, so 1 over 2. 6 minus 3x power of 1 over 2 minus 1 times negative 3. So negative 3 over 2, 6 minus 3x power of negative 1 over 2. Okay, so now become negative 3 over 2. 6 minus 3x power of 1 over 2. Or more proper, negative 3 over 2 square root 6 minus 3x. G d dx square root 3x squared plus 5. Okay, so d dx 3x squared plus 5 power of 1 over 2. Okay, here we go. So move 1 over 2. 3x squared plus 5 power of 1 over 2 minus 1 times 6x. Okay, so this one is 3x squared plus 5 power of negative 1 over 2. Okay, here we have 3x over 3x squared plus 5 power of 1 over 2. Or 3x square root 3x squared plus 5. Okay, to h, okay, so d dx square root x squared minus x plus 1. Okay, so you change x squared minus x plus 1 power of 1 over 2. So then you differentiate. Here we have 1 over 2, x squared minus x plus 1 power of 1 over 2 minus 1. Differentiate another time to x minus 1. Okay, so here we have 1 over 2. 2x plus or minus 1. X squared minus x plus 1 power of negative 1 over 2. Or 2x minus 1 over 2. X squared minus x plus 1 power of half. Or 2x minus 1 over 2. Square root x squared minus x plus 1. Okay, now question number 3. Find the value, value of dy dx for each of the given value of x or y. Okay, so y equals to 2x plus 5 power of 4. Okay, power of 4. So you must use composite function. So y in terms of x, differentiate, we get dy dx equals to 4 2x plus 5 power of 4 minus 1 times 2. Okay, here we have 8 2x plus 5 power of 3. Okay, given x equals to negative 1, then you substitute, equals to 1. Then you substitute x equals to 1 into dy dx. So 8 times 2 times 1 plus 5 cube. Okay, here we have 744. B, y equals to square root 5 minus 2x. So y equals to 5 minus 2x power of half. Y in terms of x, differentiate, we get dy dx. So 1 over 2, 5 minus 2x power of 1 over 2 minus 1 times negative 2. Okay, here we have negative 5 minus 2x power of negative 1 over 2. Okay, meaning that negative 1 over 5 minus 2x power of half, or negative 1 over square root 5 minus 2x. Okay, so we have x equals to 1 over 2. You substitute into dy dx. Okay, here I substitute, I get 1 over 5 minus 2 times 1 over 2. Okay, so 5 minus 1, 4, square root 4 is 2. Okay, so negative 1 over 2. Okay, last but not least, question 3c. Y equals to 1 over 2x minus 3. Move up. Here we have 2x minus 3 power of negative 1. Okay, so dy dx equals to negative 1. 2x minus 3 power of negative 1 minus 1 times 2. Okay, here we have negative 2, 2x minus 3 power of negative 2, or negative 2 over 2x minus 3 power of 2. Okay, so then we have to substitute x, but careful, given the value of y. So you have to find first the value of x, okay? So we get x, here we have, substitute y is 1. So 1 equals to 1 over 2x minus 3. So 2x minus 3 is 1, 2x is 4, x is 2. Okay, you substitute into dy dx. Okay, so here we have negative 2 over 2 times 2 minus 3 squared. Okay, 4 minus 3, 1, so the answer is negative 2.